Hey there, and welcome back to another daily problem video. In this one, we're going to be doing count ways to build good strings. So in here, you have 0, 1, low, and high, and you can construct a string by starting with an empty string, and then at each step, perform either one of the following: append the 0 times, or 1 times. And you can do this as much as you want. And a good string is constructed by doing this with a process having a length between low and high. Return the number of good strings that can be constructed doing this thing. And since the answer can be large, return it mod this number. So essentially, in this first example, you can basically add 1, 0 or 1, 1 at a time, which essentially lets you build any string you want, because at every character we can add just a 0 or 1, and then we're looking for strings of length 3. So basically we're going to have 3 characters, and each one of these can be a 0 or a 1. So this is just 2 to the third possibilities, which is 8. And in the second example, you're looking for strings of length 2 or 3, and now you can still add 1 0, but you have to add 2 1s. So you can't build every string possible, so there are some limitations here. So even though there's more lengths of strings that are accepted, because these numbers are greater, there's more limitations. So these are the only ones you can build. So there's 5. So essentially with this problem, you want to figure out like how to approach it. Some common things to look for, typically when you have a low and high, and this is a really common pattern, typically what you can do is you can figure out like how many strings can I make of length 0 to high and 0 to low. And then this number minus this number, or actually this will be like 0 to low minus 1. Then this number minus this number will give you the intermediate range. So in this problem, it's not really necessary because we can basically just do DP. And yeah, it's not super difficult to figure out. So essentially with DP, there's a few things you need. So the way to look for DP typically is like you have a choice of like doing something, and you do have a choice here, right? Like basically at every iteration, you have a choice of either doing this operation or this one. And so typically when you have that, you just want to look for like, is there any way I can do this with DP to make it fit in the constraints? And there is. So for DP, there's 3 things you typically want to have. You want to have a base case, recursive case, and some state variables. Probably should have written this in the other one. This should actually probably be first, and then this should be like second and third, typically. So the first thing you want to look for doing DP, like is this even possible, is look at the constraints and look at your, can I build a state to do this? So the constraints are low and high is 10 to the 5th, and 0 and 1 is 10 to the 5th. So 0 and 1 never change. So essentially all we need here for the state, we can only have one state because n squared would fail. And so here we can just have the state of like how long is our string so far, or like the index we're on or whatever. So that's going to be our state, and that's all we really need. And then depending on how long our string is, we can basically do one of these operations. We don't really care. The other thing is like, because we're asked to just get the count, we're not asked to make all these strings. So typically when that's the case, you don't actually have to build them. So you want to keep track of like the minimal amount of information you can to actually get the problem. So because we don't actually care like what the strings are, we can just maintain like how long is it, and that's it. Okay, so base case is a little bit tricky here, but there's kind of like a base plus recursive. So base is if our string is already long enough, already, you know, like low is less than or equal to our string like this, then this is 1, right? Like this is, so typically our result is 1 here, because this is like, if you want to count something, you typically have 1 when it's successful and 0 when it's not. So you're gonna have a 1 here, but you have to still recurse, because let's say we can have anywhere from strings from like 1 to 1,000 or something like that. Even though our string can be like length 5, that is valid, but we can still like have more. So this is like one of the rare cases where you kind of have like a base case. It's not like a fully base case, where, you know, if it's already here, you do start out with a value 1, but you could still do more recursion. And like the real base case would be just if we're out of bounds, right? So if our string is longer than high, then we can just return 0 here, because then we can't do anything. But if we're in the range we want, we just start out with the value of 1. And if we're not in the range we want, then we start out with a value of 0. In our recursive case, pretty easy. We just perform 0 operation, or one operation. And the only thing we need to really update there is just what index are we on next. You know, like if we perform the 0 operation, that's going to add some amount of characters, and then we're at some other thing next. And that's basically it. So we're just going to have like this base case that we're going to add on to, the recursive case, and the state variable. And you can do this in top down or bottom up. I'm going to show this in bottom up this time. I do think for this problem, this is one of the rare cases where bottom up makes a lot of sense. And so let's kind of just walk through this example here, I guess, with bottom up. So we're going to basically make a string, or not a string, we're going to make a DP array of length of the string. And so in this example too, the biggest one we care about is length 3, because anything else is invalid. So we're going to have length 0 through 3. And there's only one way to make a length 0 string. That's going to be our base case. Like basically, whenever we have length 0, there's only one way to do it. It's just empty string. And then from here, we're just going to go to all of our numbers and just see if we do the 1 or the 0, is that going to be in bounds? And if it is, we'll do that operation. So here, for example, if we perform the 0 operation, we're going to add 1 character. And the other thing is, I forgot, is we're going to initialize all these to 0. So if we perform the 0 operation, we're going to add 1 character here. So if our string is length 0 and our string will be length 1, that's fine. So we're going to say, if this is valid, then we're going to take whatever number is here and just add it to whatever it is here, right? Because basically, whatever string we were able to make here, however many ways we can do that, then we can just do the 0 operation, and then that will give us the same amount of strings in here. So yeah, basically, this will just be a 1 then. Now we're going to say, can we do the 1 operation? So if this is length 0, the 1 operation will make it length 2. That's fine. So we're going to take whatever values in here and add it to here. So this will be 1. Then we're going to go here and do the same thing. We're going to say, if we add a 0, is this going to be in bound? Yes, because that'll just be length 2. So whatever number is in here, we're going to add it to here. So that's 2. Then can we do the 1? Yes. So whatever number is in here, we're going to add it to here. And then here, we're going to do the 0. So this is fine. It'll go from 2 to 3. So we're going to add this value over here. So that'll be 3. And then can we do the 1? No, we can't, because it'll go from 2 to 4, so that's out of bounds. And then here we can't do anything because adding anything else will be out of bounds. So as we get these numbers, we're also just going to check, like, is this number in the range we care about? So it's between low and high here. So once we get this number, we'll add it to the result, and once we get this number, we'll add it to the result, and that will get us a 5. And that's basically it. So the bottom is pretty intuitive. You basically just have however many strings you could make at a certain point, and then try to do each of the operations. And if the operations is inbound, you just add that number to the next index. And then you just return the sum of this range. So that's what we're going to code and go. Yeah, I can do this one live. It's not complicated. So, okay, so first we're going to make a DP array that's going to be length of high plus 1. So use a slice, and it's going to be length of high plus 1, right? 0 to high. Yeah, then we're going to have our mod value, so we can do that here. You can do this. Let's find out. 7. Maybe we need like an int as well. I think actually for mod you need like this format. Okay, so this is our mod. DP is this, and then we're going to say DP of 0 is 1. And then we're just going to loop all the way from 0 to high, and we're going to calculate future values, and if our value is in the range from between low and high, we'll add it to the result. So we'll just say result is 0. Yeah. So I is 0, I is less than or equal to high. Okay. So first thing we'll say if I plus 0, right? So whatever length we're at now plus however long this 0 is less than or equal to high, then we can do this operation. So we're going to say dp I plus 0 plus or equals the old value plus the current index we're at. And then we can just mod at every single point here. And then we can do the same thing for the 1. So this is going to be the same exact thing. Yeah. And then the last thing we need to check for is if the I is in the range of low and high. So if I is greater or equal to low and I is less than or equal to high, we'll just add that to the result. Okay, and then so we can just return the result here because we added in the loop. Okay. So yeah, so this one bottom up is pretty straightforward. You can also do top down if you want, same kind of idea. Base case for top down, I explained in this picture. So yeah. Now, base case for bottom up, you can do a bunch of different ways, but this is one of them basically, where the empty string can only be made in one way. Yeah, so this is going to be linear and linear. And typically when you want to figure out if you can space optimize bottom up or not, you want to look for like your recursive state. So because the 0 and 1 can be like really big, we're not jumping we're not jumping like one index at a time here. Like essentially like we might go through some index here, and then whenever we take this value, we might update an index all the way over here. So we can't like make this a one space. If we were only updating like the next index, if every index only depended on the one before or the first or the previous 10 or something, then we could do it, but in this case we can't. Yeah, so it's gonna be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and yeah, I should be making these more consistently. So thanks for watching.